Hey guys, it's Vince. Today in this video, we're going to be taking a look at a YouTube content creator who made a video correcting all the problems with his CNC controller. This is a very unique video and a topic I have yet to discuss on my channel, nor did I ever have to think of discussing this, I thought, but we'll jump right in and see what your opinion is.
Hi everyone, it's Paul from This Design That. Today I'm going to be going over the CNC electrical enclosure that I have just finished rebuilding. Now this has been a very long project. One of the biggest reasons for that is that this is my first time doing this, and I don't have that much experience with electrical wiring and setting up these type of systems. It was a lot of reading and watching that I did on YouTube to get to this point.
The video is just begun and we meet Paul, the content creator, who openly explains to us this is the first time he's ever worked on a CNC controller in terms of wiring everything, and he understands there's an amount of in-depth knowledge that's required. So he spent countless hours on YouTube reviewing and reading to get the information he needed to get the job done. Now, what's interesting, and I want to bring this point up in the very beginning because, again, it's kind of contradictory. We're looking right here, and I'm going to put it on screen, at the title of his video, which is A Beginner's Guide to Building a CNC Electronics Enclosure. This, you just openly said, is the first time you've ever done this. You're already building a guide to teach others? I'm a little confused.
I think I decommissioned the CNC much early in the year. This has probably been over 6 months worth of work. But yesterday I finished pretty much most of the things with the enclosure, and I was able to get the machine moving on all axes with just a little simple program that I wrote. If your CNC has been out of operation for 6 months like mine, or if you don't even have a CNC, fear not, because you can still have your parts fabricated by using the sponsor of this video, PCBWay.
6 months to complete this project definitively proves that this is his first project dealing with a retrofit on an incorrectly built CNC controller. Guys, this takes an enormous amount of time when you're factoring in all of the video research he had to do, and then, of course, implementing what he could afford, what he understood, what questions he had, and however he decided to get the answers to those questions. And, of course, he always finds time to put in that he is sponsored, and that does help him, of course, in his endeavor, but it may not help you in yours because many of you are not sponsored, and many of you will be paying to correct any CNC control issues you have if, again, you purchase one overseas that's built incorrectly. I've dealt with it with my clients firsthand, and it's not pretty, especially when there's a business associated with that machine purchase where, once again, it can halt you right in your tracks and it could be catastrophic.
This is probably going to be a multi-part series. I'm probably going to go over a lot of things here, but then I'll also go over a few extra things in a little bit more detail in other videos. So let's start, first of all, of why am I upgrading the electronics of my CNC? Probably the number one reason was reliability.
I've said it before in previous videos, and I'm going to reiterate my point once again. If you are unfamiliar with CNC production robots but would like to get into the genre, and you go to make a purchase overseas for a robot, and you are unaware of how that CNC controller is to be built, you are essentially playing Russian roulette with your money. Because the bottom line is the overseas vendor is only going to develop what they produce, meaning unless you go in there and say, hey, I need such and such done to this machine, they're not going to make any changes. They're going to say, this is what you're getting, this is what we're marketing, and hopefully it works for you. And if you get it, it may, and if you get it and it doesn't, then guess what? You better be okay with getting with your charge, getting with PayPal, getting whoever it is that processed the payment to hopefully get your money back. Because an unstable production robot is going to cost you a lot of money to get up to speed. And I cannot emphasize that enough. Stability with robotics is everything. That's the critical point of owning a robot. If it's not stable, you essentially have a paperweight.
So this is a Omeo, I think it's an X4 CNC. It's essentially a Chinese 30 by 40 CNC. The electrical enclosure, they all use pretty much the same components from what I can see. There was a few reliability issues that I always come across with this CNC controller. So first of all, it is using Mach 3 with this controller. Pretty sure it's a cracked version of Mach 3 because there's no way to update it. You don't get a license with it or anything like that. So you are just stuck with a very old version of Mach 3.
All right, once again, we have to go back to the title of the video. He titled the video A Beginner's Guide. And I'm asking all of you, how could it be a beginner's guide when he himself was not aware that his robot came bundled with pirated motion control software? Everybody has known this for the last decade that's been involved in this industry doing any amount of research. On top of the fact, after he found that out, he should let everybody know that if you purchase a robot overseas, you're going to get pirated motion control software, namely Mach 3. Now, why is that? That's because overseas factories are concerned with building the robot, and they try to bundle a deal together to make it more appealing to people purchasing them. Once the machine hits the border overseas, you're once again on your own. They wash your hands of it, and then basically that's it. Now, I'm not saying there aren't overseas vendors that do want to see you succeed. I'm not saying that at all. What I'm saying is that there are the majority of overseas vendors that if you don't carefully find them vetted, you're going to find that your money is taken. Once it's taken, you'll get your order. Once you get your order, their hands are washed and the process is done. Now, if there's a problem, you'll have to contact your charge company or payment processor to hopefully open up a dispute to get your money back. I've been through those many times with clients. Now, the thing to keep in mind is this. If you understand these processes, you will be protected. He should be making his audience well aware that this isn't an isolated incident just with this machine. This is the way it is coming and importing robots from overseas. That being said, he brings up that Mach 3 is old. Well, yes, sir, it is old. It's the oldest motion control software in existence. And knowing that it's old, it's usually going to be better for novice end users. Why is that? Because it's got the longest legacy, and that means that if you do a Google search, you're going to find the most information about Mach 3. That is extremely beneficial to novices learning the software themselves. The other thing to keep in mind is this. He brings up a point that while it's old, a lot of guys complain about the UI or it looks old. The thing to keep in mind is that you can always update a screen set in Mach 3 for free and make it look more modern. Guys, you're not buying the latest iPhone. I don't know why these guys assume that the software has got to be Windows 11 type in order for it to be effective. The bottom line is a CNC production robot uses motion control software for its coordinate positioning system, once again from the CAM file that's loaded to move those motors into position for machining. If that does that, that's all it's meant to do. I don't understand why guys try to overcomplicate things and think that changing software is making their robot better in some ways. Some ways it may in certain instances, but for the majority of end users, Mach 3 will work fine. If his preference is for something different, that's fine, but let's always focus on where support is. And I tell my clients and potential clients all the same thing. The older the software is, the more legacy it has. The longer the legacy, the more support issues that have come up and most likely have already been solved. The other thing to keep in mind is when you purchase motion control software overseas, you're going to have a time delay depending upon where you are. Now, this gentleman I doubt is in the U.S., but everybody else that is in the U.S., we have to keep that in mind. If you're purchasing from overseas vendors, you are going to deal with a time constraint on support. Can you survive with that? Can your business handle that? If it can't, you better take that and really look at that, because that would be a priority. As I've said before, there is no such thing in CNC robotics as fire and forget as a vendor, meaning I just sell you something and the odds of never hearing from you again is pretty much nil. It's not going to happen. Always what you have to plan on is keeping that door open for, hey, I'm having this weird problem. And believe you me, I've had clients come back to me literally after 8, 10, almost 15 years now. I'll have clients come back and still ask questions. That is the business. And for some reason, guys think that you're going to purchase motion control software and it's the end of it. It's not. I have seen it happen many times. A guy is relying on this motion control software for his business, as many of you will. And then when they have a question and that company is either tied up or they're going to take 24 hours to answer most emails, that could be a time killer on you actually completing a project. So these are things we need to keep in mind. And once again, if it's really the beginner's guide, he should be making everyone well aware of this. But you can't make people aware of what you don't know yourself.
Also, I had a bug where whenever I would click on the go to 0 button, it would always go -5mm, and it would crash into workpieces so many times, and I destroyed so many end mills by forgetting about that bug and just clicking on go to 0. Another issue that I always had was running various different scripts or doing any sort of probing would always throw up some sort of error message. And then the last reliability issue that I always had was that whenever my compressor would turn on and off to cycle to fill up the tank, it would always throw an e-stop error. I was not using the same power switch, but they were running in the same room, so it could have been on the same circuit. I did find that if I connected the compressor with an extension lead to another socket in my house, in like another room, I wouldn't have that issue of the e-stop and cutting out the operation.
The content creator now goes into telling us why his system is unreliable. Now, I want to draw your attention to a couple seconds ago. He explained that the Mach 3 motion control software that he received with his machine is pirated. Now, if it is indeed pirated to all of my novice end users, that means that someone or a team of someone's went in and manipulated the registry entries of that software to allow people who didn't actually purchase a genuine license to use the bogus license and get away with it. The issue is that once those key registry entries have been manipulated, which is most likely done, you find that certain features of the software don't work, or work but not correctly. So how do I know this? Am I guessing this? No, I've had potential clients and past clients go over this with me in the last decade and a half that I've been working with this software. So I can tell you right now, it's fact that had he looked immediately at the motion control software and said, you know what, this is fake, let me replace it with a genuine license, most likely that would have corrected his issue. Now, we of course don't know if it did because he has not identified that, at least not yet. But if we're saying that, once again, the title of this video is a beginner's guide, then we should act as if we present ourselves knowing more than the average person in dealing with this software. Did he? I don't see that. We immediately went to explaining that we were breaking end mills because the software allowed the robot to move out of position when he called it to refer to 0 position. If it kept doing that, that means you essentially knew the bug was there and just avoided fixing it. And I hear this actually done a lot. This is not just a content creator's issue, but I'll never understand that logic. If you know the problem exists, we should fix the problem immediately. And how does one go about doing that if they've never troubleshooted a system like this before? The easiest way is you're going to use what's known as engineer's troubleshooting, and it just starts with a fishbone breakdown of what actually occurs with the robot and when you make a change. So what you would do is grab a legal pad, you document the problem that you're having, and then what you do is systematically begin writing down step by step what you've done to try to correct that problem and what result of that actually happened. Did it actually correct anything? Did it create more of a problem? And you keep going down that level with details until you've actually corrected the problem. Now, is this a fast process? It shouldn't be. It's got to be a detailed process. This is going to take time. This is going to take knowledge. And this is going to take persistence and consistency of accuracy of detailing all this stuff and also interpretation of those details. Because the bottom line is this: every robot in existence that does production always lets end users know key details of what it's doing. The question is, who is interpreting those details? Think about what I said. It's no different than a car. A good mechanic can look at a car and immediately know, hey, this is what it's telling you. Now we have code readers and all that stuff. We don't have that with robots, at least the ones that we're working on for ourselves. So we have to look in more detail and put together a process that allows us to troubleshoot at that level. This end user did not do that. What he actually did was he went through, saw that the software was giving him an issue, and didn't identify it yet, at least, as it being the software. He immediately went to, I'm going to refurbish the machine. Now, I'm not saying his controller was not requiring refurbishing. What I'm saying is don't throw money at stuff until you know for certain what needs to be done. And what I would have immediately done, like many of you, is I would have replaced the motion control software license with a genuine version, get rid of the bogus one, and see if your issues go away. The next issue he brought up was the compressor he was using started triggering an e-stop condition with his system. Now, keep in mind, whenever you introduce a CNC robot, no matter how big or small, to the environment you plan on working in where there's other tools, you have to keep that as a variable. Once again, documenting any change to that environment. Why? Because as you encounter a problem, it's easier to go back and dictate, hey, the major change that I made is I added this component to this environment. Okay, let's look at that component, because most likely it's going to be the reason you're having issues. When he explains that he's not sure if it's a breaker condition, how would you not be sure? That's something you should have checked immediately, because God forbid you're using too much power on a breaker, it's going to trip. And then on top of that, we want to make sure that you're going to be in a safe environment. So when he said he took an extension cord and moved his compressor out of the room and the problem went away, well, then he's just identified his problem. The issue is he's not describing this in detail to his audience in a format that they can go through and do it themselves. This is how you know a content creator, as himself, does not have the experience to once again create a beginner's guide to understanding how to work with these electronics. Guys, the fact of the matter is it takes a lot of detail to break down those variables that I just discussed. A lot of guys do not want to do that. If you do want to do it, do exactly like I said. Grab a legal pad, start documenting your machine. I have really advanced operators who can listen to their robot and within 10 minutes know exactly what it's telling them. Why? Because of experience. And also because they're paying attention to those details. You have to become that way with your robot. And if you don't want to, and you don't want to have that level of detail, then accept the fact you have to pay someone with validated knowledge to help you troubleshoot the unit.
And then lastly was the safety aspect of it. When I opened up the CNC controller to salvage some of the parts, I noticed that pretty much nothing was grounded. The EMI filter was grounded, but then from that, nothing else was grounded. The controller, the VFD, the power supply for the stepper drivers, none of that was grounded.
It's interesting, as this is a beginner's guide, that the content creator would say lastly the concern was grounding as far as safety. Because I, as a vendor, put safety first. And I, as a vendor, want you guys to understand how critical it is, not just for a stable robot, but to also understand that an insurance company protecting and insuring your home and protecting your shop is going to pay in the event you have a catastrophic failure. God forbid. This content creator, like many before him, never discussed this. They never discussed the ramifications of what occurs if an electronics enclosure is built incorrectly and how it would affect you potentially financially. See, I cover all in detail what you guys need to know, because the issue we see with content creators like Paul is that while he can create a beginner's guide as a beginner himself, when it comes to the level of detail required to work with these type of electronics, you need to be willing to take full responsibility. And in order to do that, you have to thoroughly understand what you're working with. I doubt Paul would be doing a beginner's guide on surgery for a doctor. And I wonder why that is. Because he's certainly not a doctor, and he's certainly not equipped to handle that type of responsibility.
It's going to be able to be fixed more quickly. That was the first thing I purchased. I got an AX-BBE controller, and after about an hour of playing with it and just making sure that it powered up, I put it away and got on with other projects, and I come back a few weeks later, wired it up again, was not thinking, and I plugged the 24 volt power into the 5 volt power, and I fried the controller board.
I always find it interesting when content creators put in their instructional videos what they destroyed, hoping to have the audience learn from their mistake. Instead of putting that in the video, why not just put in the video that the end user themselves actually reading the user's manual and going over in detail with the audience what they need to know to protect them from that happening? Never makes sense to me. You telling someone that you blew something up completely contradicts you being an authority. Think about what I just said.
So what I want to do is I just want to go over some of the guiding principles that led me to the way that I built my enclosure, and hopefully it will help you if you're a beginner and you're new to this. The first thing was moving away from a USB connection to the controller and going with an Ethernet connection. USB is just more susceptible to interference.
This is where the video gets really interesting. One has to wonder where Paul, the content creator, who openly admits that this is a controller he's never worked on, he doesn't have CNC controller experience with these electronics, and openly says that he had to read and review YouTube carefully for many hours to get the information he needed to make this video. So how did he find out that USB is unstable for CNC signal transmission and Ethernet is the more stable way to go? Well, it's interesting. I'm going to point out once again, that's in almost 500 of my videos, where I discuss that USB is unstable for signal transmission for CNC production robots. And this is none other than Balzis, the lead engineer over at CNC Drive, who's actually manufacturing the AXBB breakout board he's using. And you guys have seen this in many of my videos, but it's so interesting that this beginner teaching a beginner's guide came up with this. This is really interesting. Let's watch it.
Unlike the Chinese electrical enclosure, I'm actually going to use grounding with this one, and I'm going to use star point grounding, and that is essentially a common ground bus.
Well, I have to say I'm utterly impressed. I mean, for a beginner, he certainly is knowledgeable on what process he should be using to properly ground his chassis. Again, the star point grounding process I actually made a video of, and once again, I'm going to put that on the screen here as far as an excerpt. And I also want you guys to pay close attention to the ground bus that I use. Now, the main difference you'll notice between the ground bus he uses and the ground bus I use is that I make sure my ground bus is not insulated. And the main reason we want to make sure it's not insulated, you guessed it, is that it will make contact with the chassis, which is metal, and that means it's conductive, and therefore it grounds the chassis as well. Now, we don't know here if he actually attached a segregated lead from his ground to the chassis. When I say the ground, I mean the ground bus to his chassis. But in best practice, the chassis must be grounded along with the ground bus, once again performing the star point ground procedure. Now, the other thing to keep in mind is this, and I've said this in a previous video last week. When you are grounding, any type of coating that's on your chassis or any object that you're planning on grounding must be removed in order to allow for proper conduction. And once again, grounding is only truly achieved for robotics use when and only when you have a resistance of 3 or under on your ohms reading. Now again, the novice here did not pick that up. Again, it's the beginner's guide, but one can't help but really look at the direct similarities between what he's discussing as a beginner, never doing this before, and once again, what you find in my video discussing how to do the star point grounding process. It's an honest question.
Will be implemented in the enclosure, and all of the individual components, all of their ground, will go to this star ground point, and then from the star ground point it will go to obviously the mains connection. And again, this will just help reduce ground loops and interference, which interference is the thing that you want to try and minimize as much as possible with these enclosures, because obviously you are sending data, you're sending signals to drivers and to motors.
Wow, this is amazing. I thought I was the only one who really discussed how precious those CNC signals are that once again control our production robots, and how we need to mitigate EMI to make sure that they're stable and also execute proper grounding on our system. This guy is amazing as a beginner. Not to mention, one area of concern that he brought up that does need to have attention drawn to it is where he talks about a star point ground just reducing ground loops. No, Mr. Paul, it actually eliminates ground loops, because having one central location for ground, and once again just one lead going back to the mains attaching that ground bus, eliminates all potential for ground loops, because every component will be using the same central point of ground. That is the entire process of using a star point grounding system.
If possible, separate the high power and low power. So you can see with this enclosure on the right side here, I've got the mains coming in, it's going through a latch and e-stop, it's going into these distribution blocks, it's feeding the power supplies, it's feeding the VFD, and then on the left side I've got the lower power, which is the controller, the drivers, and obviously they're feeding out into the motors.
Here's where being a novice, creating a beginner's guide as a sort of an authority can get into sketchy territory. How many of his audience members will implement putting each of their voltages on each side of their electronics enclosure thinking this is going to mitigate their EMI? I want you to think logically of how many people in the forums have had unstable robots, and if all they had to do was mount all of their electronics that are high voltage on one side and lower voltage on the other side, it would actually do something. If that was the case, we would see no problems. The fact of the matter is this: if this actually worked, like I said, you'd have no problems in the industry. This would be an easy correction. The real issue is that you must implement best practice, and best practice costs money and it costs time. You will implement using double shielded cables for optimal signal reception because, again, double shields, tin braided copper first, then we have a mylar foil underneath, then we have our shield drain allocated to the star point grounding system here already identified, will allow for that proper EMI dissipation should there be any. The next option for those that do not want to deal with double shielded cable on short lead runs is implementing ferrites for passive filtration. This is fact. This is best practice. Here's another question to this gentleman. Logical. If doing this, doing once again electronics high voltage one side, electronics low voltage the other side doesn't work, you would have to implement using double shielded cable or ferrites anyways. So why in the hell wouldn't you just do it right the first time instead of putting a Band-Aid on it? This is why listening to a novice content creator act as an authority with a beginner's guide is dangerous. And this costs you money. So if anything, you guys should be upset, because if you do something incorrectly, this guy doesn't have to rebuild your system. You do.
I was trying to figure out how much distance you actually need for the EMI to not affect cables next to it. Just from what I could see, a few inches is enough to minimize the interference that cables can feed to one another.
I'm sorry, I think I missed it. Maybe you guys caught it. Where did he actually validate by increasing space between his components in his electronics enclosure that it mitigated EMI and actually produced a stable robot? I don't remember him ever actually showing that. I don't remember him actually doing anything except bringing this up in this portion of the video. Guys, once again, details are everything. The CNC controller is only one component that makes up a synergistic robot. Keep in mind that while that controller may show signs of stability when the robot is not running, when the robot is running, that's a different story, because that's what really matters. When you run an 8, 10-hour, 12-hour job, that's when you're going to find out if the robot is stable. These guys that run or show you, a jogging back and forth for 5 minutes, that's typically not what you're going to find as far as finding instability unless something is majorly wrong. Where instability usually shows up is over those longer jobs. And once again, you don't want to start a longer job unless you know for sure that that robot is stable. So how would one test a CNC controller without it connected to the robot? Because the CNC controller by itself is once again useless. This is why I tell you, be careful. The signs are there. When a guy says he's making a beginner's guide and then he openly tells you within the first 20 minutes of the video that he's a novice himself, he's not used to working with these electronics, how does that coincide? How is a beginner teaching a beginner? Once again, the level of detail we see here defines where we're at.
Yeah, hopefully this is definitely going to help. I've got a good few inches in between the high power and low power sections here.
Another brief point that I've discussed in many previous videos is the VFD should not be mounted in best practice in the same electronics enclosure as your CNC controller components. Why is that? Well, actually, there's a couple reasons. First and foremost, regardless of you using an EMI filter with the VFD, does not mean the VFD itself is not generating EMI on its own. Because again, nothing is a perfectly efficient device. There's always going to be some electromagnetic interference. The other thing to keep in mind, and this is more important to that fact, is the cooling of the enclosure. Regardless of the enclosure size, the thing to keep in mind is that when that door is closed, at least on his example, you're going to have all of that ambient heat coming from the CNC controller components along with the VFD. Now, just to show, I actually put my references so you guys can see I'm not just talking out my butthole. You can see right here from HY, Wanyang's VFD User's Manual, what they recommend when you're actually going to install their VFD. These are critical details, and for some reason, they are always overlooked. And the main reason they're overlooked is because end users, content creators like himself, they don't read the component user's manual. Now, again, he's not using an HY VFD. That does not mean that he couldn't look up the brand VFD's user's manual online to see exactly what they recommend, because that's best practice. We shouldn't take into account that we purchase components overseas, and in his case, he bought a system overseas. They're still using components. All you have to do is do a little research, meaning using Google, on the part numbers, and you will usually find user's manual or some form of documentation. If that doesn't work, you reach out to the vendor, you get the required documentation, and if that doesn't work, that should have honestly told you right there, you probably made a poor investment. So again, guys, every detail counts. We are looking for a robot to be stable. In order for it to be stable, every detail should be accounted for. If he doesn't understand the proper cooling required for a VFD, he can instigate instability just from that one variable alone. We're not even talking about the ambient heat increase for that VFD, once again, being in that electronics enclosure surrounding all of his other CNC components. These are the critical details that are most often overlooked.
The next principle is to use shielded cables, and preferably double shielded cables, for all of your signal connections.
Boy, Paul, I have to say I am very impressed. You as a beginner understanding that best practice is using double shielded cable to mitigate EMI, once again protecting those precious signals. That's amazing. But it is really interesting to point out that you contradicted yourself by actually talking about spacing components to mitigate EMI. Let me explain. What's the purpose of doing that if you plan on using, in best practice, double shielded cable? If the double shielded cable is installed correctly with the shield drain allocated to the ground bus, which you've already pointed out, you would have no requirement, nor would any end user, to separate components by their power structure. This is fact, sir. So once again, which is it? On top of the fact, many of you, like myself, have to ask that one question. Where is this guy becoming so knowledgeable on CNC components, comparing himself once again as a novice, and then saying that this is a beginner's guide? Somewhere he's getting this information, but we haven't seen any references in his video at all discussing where all of this knowledge is coming from. Really strange, Paul.
Double shielded is quite a bit more expensive than the single shielded that I can find, but I did find a decent supply on AliExpress, and I think I was able to get 10 meters of 5-core double shielded. It cost me, I think, around about £25 or £30 for it to be delivered for 10 meters, which was enough to do all of my stepper motors.
Now, Paul, you of all people should know just how important it is to select the proper double shielded cable for the desired application. There's a lot more to it than just saying this cable is cheaper than that one or selecting an arbitrary double shielded cable. We have to make sure that your audience understands that that they should be using a cable with an MBR rating. And you're probably saying, what is that, Vince? Well, an MBR rating stands for minimum bend radius rating. And that rating, once again, should never be exceeded, because if it is exceeded when they install that cable inside their cable chain, because once again, we're dealing with robotics, right, Paul? You know that. And that cable chain goes back and forth on the X and Y axis. Therefore, if that cable running within that cable chain exceeds that rating, you're going to have what's known as internal lead fracturing, which actually causes the cable to fail prematurely due to those leads within that casing failing, meaning they actually break. This is not good. And this you really should have thought about before putting an affiliate link to a generic form of double shielded cable, because again, you don't want to hurt your audience. A guy like you that carries a lot of integrity, you never want to do that. You also probably wanted to explain, but just didn't know it, how a cable can actually get an ultraflex rating, which, like my DS flexion, carries. All it would require is having internal leads that actually have yarn separators. And what does that yarn separator do? It actually prevents excess friction from falling on those internal leads when that cable once again is active within the cable chain. That way, it can carry a flex rating of whatever number of cycles going back and forth is rated by the manufacturer. This is best practice, and this will assure that if you are going to market to your audience, you're going to make sure that they're going to get the desired result that they want, including the longevity.
Sort of shielding. And the next principle is that all of the shielded cable needs to be terminated to the common ground bus. So the actual metal wire shielding that you get in this shielded cable, you need to solder a connection to that and terminate it to the common ground bus. So then the interference or the radiation has somewhere to go to, basically.
Now, Paul, we're not just trying to redirect the energy, we want to dissipate that energy. Therefore, terminating the shield drain, if your cable comes equipped with it, which I prefer, or the shield itself in his case, where he puts a lead on it, terminates it with solder and flux, and then dissipates it to the ground bus, is best practice, because that ground bus takes the energy and dissipates it to mother ground. Another quick point. We've seen in the video in the past that he's actually using for rules to terminate his ground bus with from all his leads from his shields. The thing about a ferrule is it's very small mass. I prefer ring connectors. Why? Because you have more conductive surface. More conductive surface means less problems with resistance, because again, we have a larger amount of material that's conductive. Once again, large amount of conductive material, less resistance. Smaller amount of conductive material, more resistance. This is fact.
The other principle is to use GX connections. These are the aviator sockets, and you can get all different configurations in terms of size and the amount of pins. And what I've done is I've gone for an extra pin for the stepper drivers to the stepper motors, and that is so that I can then continue the ground on that extra fifth pin onto the shielded cable that is going outside of the enclosure. So generally for stepper drivers to the motors, you would have 4 pins, but there is no way to carry that grounded shield connection into that cable that's going outside the machine. So yeah, I've gone for 5-pin GX connections for all of my stepper drivers.
Wow, Paul. Actually, I've covered these GX16 5-pin connectors used on my double shielded 18-gauge pre-built motor cables here. Or maybe you're talking about the time that I used them in my SMCU system, where it's an integrated drive system using 5-pin GX16 connectors, once again, with the 5th pin allocated to the shield drain, which I've covered in basically all of my videos. I don't know, the similarities are really getting crazy, and I think it's time that we expose some of how these similarities really pertain to my channel. Okay, I'm documenting that this video came up on September 20th, 2024. The channel's name is This Design That, Beginner's Guide to Building a CNC Electronics Enclosure. This gentleman's name is Paul, and apparently he has no problem putting in his affiliate links. He has no problem putting in where you can buy PC boards as an affiliate link. Support me on Patreon. But he really doesn't explain anything other than this one generic link here on latching e-stop of where he's getting his information from. And when he starts talking about double shielded cable, 5-pin GX16 connectors, using a star point ground system, this is all directly correlated to my channel. And what's funny is he does not reference me at all. but he decides to put up a title that says Beginner's Guide to Building a CNC Electronics Enclosure, portraying to his audience, as I'm stating in this comment here that I'm leaving, that he's an authority. So right now I'm documenting this and I'm giving him 24 hours to correct a video by explaining in it my channel was the resource you used to become so knowledgeable on a topic that you felt you were able to teach others using my information. And I'm going to comment on it. Now, I did that, Paul, because I figured if no one is looking, I wanted to see exactly how you'd react. I get asked by a lot of my audience members and people out there who like to troll. They'll say, you never contacted the content creator. Well, guess what? Now I did. And I wanted to see if maybe he just comes forward and says, hey, you know what? I overlooked this. I'm going to give links to your channel. I'll put links to all the resources I use to get knowledgeable, because that's the respectful thing to do. Hell, in colleges in the US, that would be considered plagiarism if you're just stealing stuff and just posting it. So in essence, that was why I contacted you. And I wanted everyone to see exactly what comment I got back, because I think it's going to be eye-opening and it proves my point, as I've said in many previous videos. Let's look at this. Okay, so we're on Paul's channel again. And what I want to point your attention to is, first and foremost, you can see that he's edited the description to now include what he claims is the sources for the helpful information on the topic. And you can see here we just have some names of forums, and then underneath that some names of YouTubers. But we have no direct links in the video, once again, of any of the resources that he's used, actually showing the resource. He's just arbitrarily listing names. So let's see what his comment was with the reply from mine. Hi, Vince. Sorry to burst your bubble, but your influence on my design choices for the CNC enclosure was very minimal, probably less than 1%. While I appreciate the effort you've put into your content, to suggest that I've heavily relied on it is far from accurate. I tried to watch a few of your videos, but I quickly turned to other sources for a few reasons. Some suggestions for improvements. Audio quality. The constant background noise, especially the fan, makes it really hard to focus. Learn how to use noise removal, or just turn off the fan during recording. It would make a world of difference. Camera work. The low resolution, unsteady footage was distracting. A tripod and a better camera would definitely improve the quality of your videos. Video length and editing. Your videos tend to drag on far too long. Some tighter editing and the use of timestamps would make it easier for viewers to skip to the important parts instead of watching 40 minutes for a few key points. And then he says down here, I spent hundreds of hours researching this topic. And here's where I got the vast majority of my information. Once again, my name under YouTubers is not listed. He finishes up by saying, your content made up less than 1% of my overall research. But I still appreciate your contributions, however small they were, and he gave us that swell thumb up emoticon. You seem to enjoy the drama side of YouTube, so I'll leave you to it in your little corner on this platform. All the best, Paul. Well, Paul, you of all people should know I really tell my audience the truth. And with a person like you telling me you only used less than 1% of my information, yet in order to do less than 1%, you were able to criticize my channel dealing with the audio quality, my camera work, my video length and editing. That seems really strange. And I think, Paul, I probably have more resources on the internet than you do. Let's see if I do and I can expose some real truth. All right, so to show you guys exactly what I did, because again, this isn't rocket science, there is going to be transcripts done on every video. Well, after looking at the channels that, once again, Paul listed under YouTubers, you guys will notice there's only 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Well, actually, the last one does not exist, DIY CNC. Nothing. So we actually only have 9 channels that he actually listed. So then all I did was search the actual terms inside of YouTube to see for if these terms were used at all within the transcripts of any of the channels he listed. So we'll start from the back and go to the front. Let's just see what we find, because again, less than 1% should be easy to find. There should be a lot of information here. GBWM channel. We search for CNC controller grounding, start point ground, USB unstable, GX16 5-pin connector, and double shielded cable. Okay, and you can see there's no terms found in any of those videos on that channel. Next channel, CNC 4XR7. Once again, none of those terms on that channel. Keep going. Making stuff, you guys can see the results. Build Bug, John Ward, Projects by Brian, Uptime Fab, Build Your CNC, Winston Moy, good channel too, by the way, and Corvette Guy 50. Oh my, what have we got here? Holy cow. Let's see. Look at this. And that's just those terms. So other than line 2, it comes down to line 583. So basically -1, we have 582 lines with actual timestamps of when these terms are used, and it doesn't even really take the timestamps. You can see match text, double shielded cable, shielding, star point ground. I mean, we can see this as we go through here, and it's pretty apparent that I would think there's more than 1% here. What do you think, Paul? What do you think? Because, again, if I'm making this up, how would these terms only be found on my channel? That's pretty amazing. Once again, to clarify it, here's the term: CNC controller grounding, star point ground, USB unstable, GX16 5-pin connector, and double shielded cable. There you go. But let's discuss this a little further, because there's even more to this. All right, so we're on Paul's channel again. And I want to draw your attention to a comment that someone left on his channel. And it says here, basically, Vince deletes comments that question or call him out. Notice they're all positive. And realistically, the only thing I delete is comments that are truthfully bullshit, meaning you're trying to spread misinformation, which unfortunately happens quite a bit. And I will show you right here that this gentleman wrote, also, shielding still works when it isn't grounded. That's interesting. And then he writes over here, P.S. don't fall for the double shielded snake oil. That's interesting too. So I decided to respond to his comment with truth and evidence. Here's actual links in Google. I bring them up. Shield drains must be grounded to dissipate EMI. Yes, shield drains must be grounded to dissipate electromagnetic interference EMI. This is not me saying this. This is well within Google. So we go back here. Double shielded cable is snake oil. Why do spindles require it? I asked him. Oh, wait, you need more proof. Here you go. Click this. Double shielded cable is more effective than single shielded cable for CNC applications. And yes, double shielded cables can be more effective than single shielded cables for CNC applications. Once again, I'm not making this up. This is all fact. So after that, here's what gets interesting, because Paul's an honest guy. This is the kind of guy he wants to portray. And what's really hysterical is this guy does reviews. Okay, so we're back on Paul's channel. And right here was that original comment from the gentleman. And then you'll notice that underneath that, where my reply was, it's gone. Not only is it gone, but Paul replied, Hi, Gareth. Thanks very much for the input. Of course, he left his heart. I knew I'd get a few things wrong when I published a video, haha. I've been testing continuity a lot on this enclosure and did notice that the GX sockets were grounded when I was testing, but I wasn't sure, so I thought I'd get less resistance if it was wired connection through the GX socket for the ground. It's good to know this, though. Noted on the double shielding, and makes sense when you show the TV signals as an example. Is that interesting or what, guys? In the end, Paul, all of the information is now out, and your audience and my audience can sit back, review it all, as long as it is, and make their choice on what the truth is. The bottom line is, guys, I'm going to put up on screen his about section on his YouTube videos so you can see exactly what skill sets he possesses. Naturally, he has a filmmaker background, which I think we can all attest to, especially from the critique you've gave me. And you know what? You're probably right. I'm certainly not a filmmaker. I don't pretend to be, unlike some people. But I can't help but reminisce on a time back, February 10, 2007, when Joe Rogan went on stage at the Comedy Store and confronted Carlos Mencia for stealing jokes. And if you guys haven't seen this video, I highly recommend you take some time out of your day and watch it. It's amazing. And this incident really is reminiscent of that because, again, I can never, ever understand why someone would try to pretend to know something or be something they're not. It just doesn't make sense to me. How this gentleman can make a beginner's guide to anything and utilize someone else's information, never giving him credit, and be okay with that. To me, there's something ethically wrong with that. And the real kick in the ass is this guy is actually doing review videos, hoping to portray his audience of actually purchasing whatever he's reviewing. Something else I want to point out, just a quick detail, is that in his About section, he doesn't list affiliate marketer. And yet that's exactly what he's doing in his channel. And if you think about it, the real reason I feel that he never actually gave me credit for any of the information is because he was selling his own product, double shielded cable, which he knew he'd be competing me with. And that doesn't make logical sense, not in his eyes. So in the end, it all comes down to you guys protecting your money with everything you have. And once again, vetting as many content creators as possible. Check all the information. You guys can see behind me, I actually have a change of scenery, and that's because Hurricane Helene has killed the power and the water to my house. But that's real minor compared to what most people are experiencing. So please say your prayers for these people. If you can donate, please do that. They definitely deserve it. And once again, Paul, I didn't care if I had to walk to the end of the earth. This video would have been done. Thank you all for your support. Take care.